Hello everyone, welcome to my presentation. I'm Du Song, a PhD candidate from the Hong Kong Polytechnic University. Next, I will share a research work from our research group. Hilbert's agent, large language model-based framework for robotic construction by leveraging IFC. In recent years, there are some challenges in construction. For example, the labor shortage, aging workforce, high safety risks, and low work efficiency. These issues are especially severe in Hong Kong. For example, the number of construction workers in Hong Kong is decreasing year by year. So, to address this challenge and achieve sustainable development of construction, Hong Kong is actively exploring the automated construction methods. In the field of automated construction, many different methods have already been used to automate the construction process. Typical examples include 3D concrete printing, bricklaying, and assembling repackage. However, these methods usually focuses on a single task and rely on pre-programmed control. The flexibility of these methods is limited, like a rule-based method or template-based method. For example, a robot designed for bricklaying cannot be used for 3D concrete printing. Therefore, this study aims to improve the adaptability and flexibility of automated construction methods. In recent years, several studies have tried to make automated construction system more flexible. These studies all introduced the idea of an agent. For example, Dr. Du proposed a framework. He combines natural language description and function sites to achieve the flexibility to build different building models. Dr. Qin realized the one-click design and analysis of different building structures. These studies have demonstrated using the agent's capability in semantic understanding and reasoning in the construction tasks processing stage. The flexibility and adaptability to different construction tasks have been improved. Inspired by this, we believe that the agent can also help construction robot perform different construction tasks. Agent-based method to realize automated construction, which means that the agent needs to generate a corresponding robot control command according to the different construction tasks. This involves two stages. Firstly, the agent needs to get the building data from the construction tasks or the construction files, and then generate the control command for the construction robot. Both processes pose challenge to the agent. Construction tasks or construction files typically contains a large volume of building data. This poses a challenge to the agent's token capability. In this study, we introduced a memory module to persist the data and avoid repassing building files. Second, the agent may create hallucinations when generating robot commands, which is known issue for the large language model. To reduce this risk, we have built a toolbox of well-defined functions for the large language model to call. So next, I will explain the memory module and the toolbox in detail. This slide shows the typical agent framework. Agent continuously perceives the environment to obtain observations, make planning decisions based on the observations, and perform corresponding actions to influence the environment over and over again. We provide some prompt as shown in this slide to help the agent perceive the environment. In the processing loop of the agent needs to generate commands based on the information of the building tasks. To avoid generating hallucinations, we defined the function. This function can only call these definite functions, which reduce the generating hallucinations. In addition, different commands require different building data. To avoid repeating searching of data by the agent and reduce the token volume, we stored all the data obtained by the agent during the data processing stage in a memory module. We use JSON format for this storage. And this agent can then access this data at any time. These organizations improve the efficiency of data processing. The process of using this agent. The operator provides a task description and a prompt. After receiving the prompt, the agent first checks whether the memory already contains the needed FC and semantic data. If not, it calls the corresponding functions to process the data and generate commands. The generated data are written into the memory module during data processing. The final robot execution, the final robot commands are executed on-site or in a simulation. As shown in this slides, we use this module to validate our measures. First, the worker input the FC files and prompt. The agent loads the prompt. And the agent decides whether the FC files need processing. If yes, it calls the relevant functions and writes the processed data, such as brick coordinates, into the memory module. After the relevant functions run, the processed results, such as brick coordinates, are saved in the memory. In this case, we want to achieve bricklaying and 3D concrete printing. So the agent generates robot code for bricklaying and 3D concrete printing. In this case, we test 10 different tasks and achieved a 100% success rate. The simulated execution of the generated robot code is shown in these slides. Task 5 shows the process of bricklaying. Task 6 shows the process of 3D concrete printing. And the demonstration confirms the flexibility of our measures. We also compared the agent with and without the memory module. The results shown that using the memory module reduced the processing time by 60%. And these results validate our measures' efficiency. We built an agent-enhanced large language model agent framework. This framework lets natural language or building files directly drive robot actions, and it provides a new reference method for construction automation. This slide shows the reference I mentioned during my presentation. Thanks for your listening, and I appreciate any questions or suggestions you may have. So, thanks.